Okay, so let's continue. Let's continue our lesson on linear models. Let's discuss results F1. So let W be a subset of your subspace V. We are to show that the projection of Y onto B mode W is just the difference between the projection of Y onto V and the projection of Y onto W. Now recall that V mode W is expressed as the intersection of V and W perp. So for easy notation, let the vector U be the difference between the projection of Y onto V and the projection of Y onto W. So that if we want to show that U is if we want to show that U is the projection of Y onto B mode W, then we have to show that U is in B mode W by definition of projection, and Y minus U is in B mode W perp. No? So recall when we define projection, we say V is a projection of Y onto V. We want to show that V is in V and Y minus V is in B perp. So equivalently, kini man projection of Y onto B mode W. So it is, and if we define this to be U, then we want to show that U is in B mode W and Y minus U is in B mode W perp. Okay. So since W is a subset of V, then the projection of Y onto W is an element of W. Kaya naman na siya projected sa W. So naa siya sa W, which is a subset of V. So we see that the projection of Y onto W is an element of V, and the projection of V Y onto V is obviously an element of V. And then U is just the difference between the projection of Y onto V and the projection of Y onto W, which are all element of V. So implies that U is in V. Then we are U is in V. But we have to show that U is also in W perp, so that it will be in V mode W. So in here, we showed that U is in V. Next, we also have to show that U should be in W perp para na siya sa V mode W. So to show that U is in W perp, we arbitrarily choose a vector to be in W, and then we get the inner product of U and W. If W is in W, and we want to show that U is in W perp, we want to show that this is in W perp, we have to show that the inner product here is 0. So U is the difference between the projection of Y onto V and the projection of Y onto W. This second line is just the linearity of projections and application of inner product. You have this. And then you have a result, lemma 2.2, that if Y is in V, then the projection of Y onto V is just Y. the same thing here. If W is in V, if W is in V, then the projection of W into W is just this. So ibig sabihin, this is true. Obviously, W is in V. So this is just is in W. So this is just W, and that is equal to 0. So here we repeatedly use that lemma. Let me scan through the book. Lemma 2.5C, no? So the argument here is repeatedly using theorem 2.5C. That is the projection of Y onto V is just Y if Y is in V. So that we obtain that the inner product of U and W, the inner product of U and W is just 0. It's just 0. This is just equal to 0. Then it means that U is in W perp. So it's in W perp. It is also in U is also in V. Then it must be that U is in B mode W. So we are done with this part. The next thing that we have to show is Y minus U is in B mode W perp. So to show that, we arbitrarily choose a vector in B mode W, and then we get the inner product with Y minus U and show that it is 0. That's the usual way of showing that it's in W perp. So arbitrarily choose a vector to be in B mode W, get the inner product with Y minus U. So this is Y, this is U, then V. This is just usual operation. And then group this vector with V, and then this vector with V. Okay, so the question here now is, why is this inner product equal to 0? Let's start. Why is this 0? Because by definition of projection, Y minus the projection of Y onto V is in B perp. So this is in B perp. This is an element of B perp. And V here, where is V? V is an element of V intersection W perp. So V is in V. So this is an element of V. So any vector in B perp, inner product with element in V, that is 0. Okay, so this is correct. Question? Did you understand?
Yes, ma'am.
So this part is okay. And then let's look at this. That is 0 because V again is also in W perp. And the projection of Y onto W is in W. So V is in W perp, projection of Y onto W is in W. Then the inner product is 0. So we have shown that if V is in V mode W, then Y minus U is in V mode W perp. So that the vector U is actually the projection of y onto B mode W. Okay, so you see in the many routines here, you just use the definition of projections and use the concept that if a vector is in a subspace and the other vector is in its perp, then the inner product is equal to 0. So that's the mostly of the routine of the proof shown. Next, we have F.2. So here, I think this is just from the previous result, since we have shown here that the projection of y onto B perp, B mode W is just the difference between the projection of y onto V and the projection of y onto W. So if you get the square norm of that, so unsay nahitabo, naa kay say C is equal to A minus B. So kung kaon dahil nimo ang C square, according to this, is just A square minus B square. So although kung algebraically, kung imo nang i-expand, dapat C square is equal to A square minus 2AB plus B square, di ba? Mo man ang algebra na to. So ang nahitabo din kini siya can be expressed as a B square. Para mahimo siyang 2B square plus B square. So mahimo siyang A square minus B square. So ibig sabihin, kining inner product niya can be expressed as a B square. Okay, so let's look at the proof of this. So you know that from the previous result, rewriting it, you can write it as the projection of y onto V is the sum of the projection of y onto B mode W and the projection of y onto W. Getting the square norm of both sides, you have that. And then, mo ni siya mahitabo, C square, C equal to A plus B, get the square, equal to A square plus 2AB plus B square. But this one actually is ang inner product na siya sa duha, but that is just equal to 0, no? That is equal to 0. Why? Because this is an element of where? W.
W.
And this is an element of W perp. Okay? So that is, so kining middle product diha, mahimo ng 0 lang. Okay? So you have seen here that we have shown that the square norm of the projection of y onto V is equal to the sum of the square norm of the projection of y onto B mode W and the projection and the square norm of the projection of y onto W. So that rearranging the terms, you will have what you want to get. Okay? Next. So this is your next exercise. Aside from the problem set, wala pa man ko gi-set sa problem set, no? But this is your next exercise, letter G. So if V is orthogonal to W, then the projection of y onto W, the projection of the projection of y onto w onto v, which is, you can remove the parentheses there, is just 0. And the projection of in matrix form, actually maura man ni siya, no? Matrix notation ra na, and that is equal to 0. And you can use the result, part 2 of, to prove this. This is just similar to the earlier, except that what we'll use is theorem 2.5 C, part B, 2, which says that the projection of y onto v is 0 if and only if y is in B perp. No? And you also use the definition of projection. So the proof of this is an exercise. Next, you have your first exercise 1.19. This is your second exercise. So you just label it, say theorem ani, theorem H naman eh. Say before ani. Say theorem ani sa Arnold 2.5, no? You just label this theorem exercise theorem 2.5G. Okay? So I will give you 1 week for this to solve this exercise. So today is Thursday. This will be due next week, Thursday. Are you with me? So this is aside from the problem set, no? This is just an exercise. Okay? This will be exercise 2. Label it exercise 2, Theorem 2.5G. Are you with me?
Yes, ma'am.
Okay.
Yes, ma'am.
Next, we have H. H is, let X be a basis matrix. Then we are to prove that this is just the square of the projection is just the projection, and the transpose of the projection is still the projection as long as X is a basis matrix. So recall that we use this notation as a matrix notations for the function of FB. And from theorem 2.4C, the projection was, if X is a basis matrix, can be written as, in terms of X, it's X prime X inverse X prime. So if we get the square, so this is your PB times PB. And then this is just matrix, so it means that our dimensions here are conformable. So pag matrix multiplication, pwede ra na adjacent. So kini siya ma-adjacent ra siya na. I emphasize it with parenthesis here because with the inverse, that is just equal to I. So what is left here? So since X prime X is invertible, the inverse exists and it's unique, and X prime X inverse X prime X will be equal to I. So if that is I, what is left is this X, then X prime X inverse X prime, which is actually equal to your PB. So if we also get the transpose here, again, recall ABC transpose is equal to C transpose, B transpose, A transpose. That is properties of your transpose. So X transpose is just X. So this is X, and then X prime X inverse transpose is just equal to kini X prime, man kini X prime prime, it's X, and then inverse. So pwede man sulod nimo ang, if you have A inverse, get the transpose, that is just equal to A transpose, and then outside ang inverse is just the same. So get that inverse of this transpose, it's still X prime X inverse, and then get the transpose of that, which is X transpose there. But this one is actually just equal to your PB. So if your X is a basis matrix, the square projection is just equal to the projection, and the transpose of the projection is just equal to the projection. Okay, next, let's have a definition of your trace. Recall that the trace of a matrix, of a square matrix, is the sum of the diagonal elements of A, that is by notation, the trace of A is just equal to the sum of the I from 1 to N. And we have some properties of the trace. So if your matrices, if you have two matrices which are square, and you get the sum or the difference of the matrices and get the trace, is just equal to summing the traces for each of the individual matrices. Next, we want, even if it's not square, as long as the product is conformable and it becomes a square matrix, because trace is defined only on a square matrix. So if you have two different matrices, say N by P and P by N, as long as we get the product which results to a square matrix, then you can get the trace. The trace of AB is just equal to the trace of BA. So take note that AB or BA should be a square matrix. And for a square matrix A, the trace of A is just equal to the trace of the transpose of A. So these three are important properties of your trace. The next, why I've discussed those terms, because the next theorem, or the next part of the theorem, which is I, talks about the trace of the projection PB. So if the dimension of your subspace is P, then the trace of your projection is also equal to P. So let the dimension of B be P, and the projection, if X is a basis matrix, is X, X prime, X inverse, X prime. Then the trace of the projection, substitution, you have that X, X prime, X inverse, X prime. What happened here? We use theorem 2.6b. That is, the trace of AB is equal to the trace of B. So here, so what we did here is, this will be your A, this will be your B. So the trace of AB is equal to the trace of BA. This is your B, and this is your A. Okay? Okay?
Yes, ma'am.
So we use this. The trace of AB is the trace of BA with A as X and B this whole thing. So that we have X prime X inverse now with X prime X, and we know that X prime X is invertible, so the inverse exists, and if we multiply X prime X inverse with X prime X, that is your identity matrix. Identity matrix has the diagonal equal to 1 and the diagonal equal to 0. So if we add the diagonal entries of an identity matrix, and your matrix is P by P because it's of dimension P, then there will be P1s. So that's why the trace of the projection of a matrix projection, the matrix PB is, the trace of that is equal to P. Okay. So one of the most important aspect of matrix PB is that it does not depend on particular basis matrix chosen, thus improving results about projections. We can always assume that our basis matrix is orthonormal. Ortho mean that any vector ij that is different is equal to 0. Normal means the inner product of a vector with itself is equal to 1. Okay. So this leads us to the next theorem in Arnold, which is theorem 2.6. So if you have a basis matrix which is orthonormal for a subspace V, then X prime X is just equal to the identity matrix. Next, the projection of, di ba, ang projection of Y onto V sa previous result sa theorem sa theorem 2.4, ang general, as long as you do not know about your X, if it is just a basis matrix, then the projection is given as X prime X inverse X prime, no? Itong ganina. So if in particular ang atong basis matrix is orthonormal kay because of this remark, no? In most one of the most important aspect of the matrix PB is that it does not depend on a particular basis matrix chosen. Thus, in the rest of our discussion here, we will assume that our basis matrix is an orthonormal basis matrix. So if that is satisfied, what will happen is that our X prime X here will just be equal to the identity matrix. The projection will be simplified as X prime Y, because this will be identity, and then you get the inverse of that, it's still the identity. So X identity X prime will be equal to X prime. Okay. And the next result, if you have a orthonormal basis, is that the square norm of the projection of Y onto V is just equal to the square norm of X prime Y square. So look at the difference of that, no? So kung kaunin mo ang square norm ani, matangtang ni siya. May siyang square norm ani. Okay, so let's check. That is on the condition that X is an orthonormal basis matrix. Okay, so let's start with the first one. So if X is an orthonormal basis matrix, this is the assumption, then our x prime x is just equal to the identity matrix. So if it is an orthonormal basis matrix, then for each of the vector xi, okay, ortho and normal, this is normal, correct? That is by definition, and this is being ortho. So kung ang imong basis matrix din pagkuha nimo sa x prime x, x prime. So kung kuha nimo tanan x11, x21 kay prime naman na. And then ipares nimo sa x11, x12 and so on. Pag ana nimo multiply nimo sa may tabo. Ang tanang parehas og entry will be equal to 1. Correct? Tanang parehas entry mahimong 1. Ang tanan of diagonal mahimong 0. Are you with me? No? Kay pag ana man good nimo x11, x ang prime ani is 21, x12 and so on so forth. Man dinhi x prime x man ang x11, x12, x21 kay transpose man. So pag ana nimo pak kini siya og kana may man na siyang 1. Pero tanang dili pares may mo siyang 0. So dinhi mag-abot na pud si x22 ug si x22 mag-abot sila 1. So may mo siyang identity. Ang x prime x will be equal to the identity matrix. So that is why x prime x, if x is an orthonormal basis, will be the identity. And then the projection of y onto v, which is by definition is your x prime x inverse x prime y. But this is the identity. Get the inverse of identity is still the identity. So what remains is x prime y. So done. Next. From here, get the square norm. By definition of square norm, that is equal to the inner product, no? Anong square norm of u square is actually u, which is u prime u. Or our u here is x prime y. So prime and prime there. Get the prime of this. X prime y prime. Una si y prime, then kini si x prime prime, so x, then x prime. So you have y prime, x prime, then x prime y. But x prime x here is your identity matrix. So it means that this part here is your identity matrix. So what is left is y prime, x prime y. But this part here can be rewritten as x prime y prime, no? Because x prime y prime is actually y prime x, which is y prime x here. Then x prime y. By definition, this is actually the inner product of x prime y and x prime y, which is by notation, that is the square norm of x prime y. So we see that the projection of y onto b, square norm, is equal to the square norm of x prime y. Question? Nasabtan ra?
Yes, ma'am.
Okay, next. So, this is lemma 2.7 in Arnold. If our x's are mutually orthogonal non-zero vectors. Sa ganun ng orthogonal? inner product of xi, xj is 0 for I not equal to j. Mutually orthogonal. So tanan. Then we say that the x's there are linearly independent. Linearly independent, kung sa ganit pasabot ana, kung naakay linear combination equal to 0, mag-imply ni siya na ang tanan AIs nimo is equal to 0. Then your XIs here are linearly independent. So to show that the XI are linearly independent, you assume that this linear combination is 0 and show that all of the AIs here are 0. So assume that it is equal to 0. So if you get the square norm of that, because to use this assumption, you have to relate it to your square norm. No? You have to relate it to your square norm. So what you do, from your assumption here, get the square norm. But this is just, since this is just a constant, so this is the square norm is just related to your the square norm of the vectors. So when do you say that AB is equal to 0? AB is 0. You have two conditions. A is 0 or B is 0. But in our assumption here that the x's here are non-zero vectors. So wala ni siyang B is equal to 0. And this will force us non-zero and then mutually orthogonal man. So ang in itself, ang xi inner product with xi will just be equal to 1. So this will force us that the AIs here should be equal to 0. So which means that the xi are linearly independent. Okay, next. Lemma 2.8. Let W be a subset of the subspace V, and V is a subset of R to the N. So the dimension of V is not equal to N, but it can be equal to P where P is less than N. Kay subset naman siya sa R to the N. So ang whole space nimo is N. So the dimension of the perp will be the whole dimension minus the dimension of V. So if the dimension of V is P, then the dimension of B perp will be N minus P, no? So kini ang whole space, subset ra ang B, man subset pag yun ang W. So ang W din will be N minus the dimension of V. Now, to prove that, you have to have a knowledge about linear algebra, about expanding the vectors. That is, your whole subspace N can be written as, because if you look at this, N is actually equal to the dimension of V plus the dimension of B perp, no? So this has something to do, dimension has something to do with the basis for each of the subspace in your linear algebra. So for easy notation, let's denote the dimension of V by P and the dimension of B perp by K. So if you have a subspace, each of the space here there has its own orthonormal basis. And where do you find that? You have that in lemma 2.1a. It says here that if V is a subspace, then V will always have an orthonormal basis. So kung subspace siya, naagin na siya iyahang kaugalingon orthonormal basis. So because that lemma, that orthonormal basis always exists for a subspace, we can always let say x1 to xp. We know the dimension, so mao po na ang number of vectors. Ang basis man god will depend on the dimension of your space. So let x1 to xp be orthonormal basis for p, and you can always expand xp1 plus 1 to xp plus k to be the orthonormal basis for BPERP. So how many vectors are there? This is p plus k minus p plus 1 minus 1. No? For example, mag-count mo from 1 to 10. 1 to 10. 12 na lang. 1 to 12. Pila ka book elements na ana. Diba ana na siya? 12 minus 1 plus 1. Which is 12. No? So, the dimension of this, pila ka book vectors ni will be p plus k minus p plus 1 minus 1, which is actually equal to k, which is the dimension of your BPERP. So x1 to xp will be the orthonormal basis for V, and there are p of them because the dimension of V is p, and xp plus 1 to xp plus k will be the orthonormal basis for BPERP, and there are k of them. Okay? So, kini siya, nahitabo ni siya tungod sa lemma 2.1a. Kay kung ang kung nakay isa ka subspace, na siya iyahang kaugalingong orthonormal basis. So, we have that. And then tungod kay orthonormal basis siya, we have these conditions. We have these conditions that the inner product for xi and xj, where I ranges in these conditions here, will be equal to 0 since orthogonal man ang duha ka subspace. Also, by the previous lemma, 2.7, kay orthonormal siya, so orthogonal siya, then the x's there are linearly independent. Okay, what do you want to prove? We want to show that the dimension of BPERP is equal to n minus the dimension of V. So next we show that the xi spans your Rn para makuha nimo ang dimension sa tanan. So let U be a vector in Rn. Then by theorem 2.5d, naman ta ato no, the projection of U unto BPERP is the difference of the vector minus the projection of U unto V, so that you can write U as the sum of the projections. Mao man ni atong gisgutan sa una na the original vector is equal to the projection plus the rejection. No? If you recall, ang projection nini, katong projection na nasa BPERP mo to yung rejection. So the original vector is equal to the projection plus the rejection. Okay. So since you know that any projection onto V is in V and V is a subspace, you can always find constants AI such that you can have a vector in V as a linear combinations of some vectors in V. This is by definition of a subspace, no? Again, by definition of a subspace, you can always find constants AI here such that any vector in V can be written as a linear combination of the vectors in V. Now, xi here are vectors in V, which is actually the basis for V. So this new vector here, we call the projection of U onto V is, say, the linear combination of the orthonormal basis for V. Similarly, for the same reason that B-perp is a subspace, you can always find some constant Bi so that this vector here, which is an element of B-perp, can be written as a linear combination of the orthonormal basis for B-perp. Again, recall that xp1 to xp plus k are vectors in B-perp. So pwede kayo nimo isulat a new vector to be a linear combination of those vectors by definition of subspace. So that since U can be expressed as the projection of U onto V plus the projection of U onto B-perp, then U is the sum of these two new linear combinations. And with that, Xi expands to Rn. No, because this is in V and this is in B-perp. So ibig sabihin maka-expand siya until the whole space. And so that combining the xi's here from 1 to p and xi from p plus 1 plus p plus k, xi form a basis for Rn. Therefore, the dimension of Rn will be the dimension of x1 until xp plus k, which is equal to p plus k, so that n here is equal to the dimension of V plus the dimension of B-perp, resulting to what we want, that the dimension of B-perp is equal to n minus the dimension of V. So, as another exercise here, you are to show that the dimension of B mod W is the dimension of V minus the dimension of W. So may tabuan na dimension of V intersection W perp. No? And then you show that this is equal to the dimension of V minus the dimension of W. But we know that the dimension of W perp is equal to n times the dimension of W by the previous result. So I think this is easily obtained. So this is another exercise together with, this is under exercise 2. So you have two numbers for your exercise 2. One is exercise 2 will be theorem 2.5G and theorem 2.8B. Okay, 2.8B. Okay, so that is exercise 2. Questions? Am I going too fast?
Okay naman, ma'am.
Okay. Next. Lemma 2.9. The orthogonal subspace of the orthogonal subspace of V is V. So, ibig sabihin, kung nakaka sa V perp, kuhaonin mo ang iyang orthogonal, mubalik ka sa imuhang subspace V, no? So remember, you can always relate it as an X and Y axis. So kung kini imong V, mo ni imong V perp. Kung kuhaonin mo ang perp ani, mubalik ka sa V, di ba? Okay, so B per perp is equal to V. So to show two sets are equal, A is equal to B kung set. Di ba sa inyong set theory, A is a subset of B and you show that B is a subset of A, correct? So ang clear daw ani kini. B per perp is a subset of B. Kay mao man ni ang general na space, no? So any subset ana or particular na set ana is always a subset of of the space V. So ang atong kinahanglan is unsa? To show that V is a subset of B per perp, which is mura siya general paingon sa particular. So dili na siya obvious, dili na siya clear. Pero ang clear, any derivation from that set is always a subset of the whole set. So that is clear. So ang atong aim ani is to show that V is a subset of B per perp. So let's use lemma 2.1F. Kay mao ni iyang gamiton. So before using that, tanaw na to unsay mga assumption anang lemma 2.1F. Lemma 2.1F. Let me have a space. Okay. Mao ni ang lemma 2.1F. Can you see my slide? Bisan gidako nako.
Yes, ma'am.
If W is a subset of V and dimension of W is equal to the dimension of V, then V is equal to W. Okay? So, dinhi na lemma, duha ang kondisyon. Dapat mapakita nimo si W subset sa, so unsa to atong gusto? V is a subset of B per perp. So, ang obvious, B per perp is a subset of V, no? So, if W is a subset of V, tinuod na siya. So, ang atong ipakita na lang is the dimension. So, dili na kay lisod na ipakita. Dako man, ang dako a subset sa particular, lisod na ipakita. Kini atong gamiton. So, if W is a subset of B, tinuod na. Ang atong ipakita is the dimension of B per perp is equal to the dimension of V, no? Mao na lang na ato ipakita para magamit na natong theorem 2.1F. Okay. So, suppose na ang dimension sa B is P. Man from the previous result, ang dimension sa B perp is N minus P, no? Because that is the dimension of N, the whole space N minus dimension of V. So kung applyan na nato, applyan ni nato na result kini siya. So ang dimension sa B per perp, so mao na ni imong space gyud na B will be equal to n times the dimension of B perp. So kini siya will be n minus the dimension of B perp. But the dimension of B perp is n minus p. Mao ni siya. So that n minus b minus p is p, which is the dimension of V. So unsa man atong napakita ani? Ang dimension sa B perp is equal to p, which is the dimension of V. So magamit na ni natong lemma 2.1f. Kung mapakita nato na subset, which is this, and then the dimension of W is equal to the dimension of V, then V is equal to W. Okay? So B per perp is equal to W. Okay? So easy with lemma 2.1f. With this lemma. With this lemma, no? Becomes easy kaysa atong ipakita na V is a subset of B per perp. Lisod ni siya kay general, dako man i-subset nimo sa particular. So the trick there is to use results. Okay, next. The same thing here. W is a subset of V. We are to show that B mode W is just W. Okay, this is assumption. By this assumption, if we let W be in W, then W is also in B. This follows from the assumption. Now let U be in W mode V mode W. This means that U is V in V and U is in B mode W. So that joining these two means that the inner product of W and U is 0. Okay, that's the reason. W is in W and U is in W perp. So that W is in the B mode W. Nga naman. Unsa gani pasabot sa W na sa B mode W perp? W is in V intersection W perp. No? Nganong nakasulti man ta na si U nasa si W nasa B mode W perp. Si W ha, si W nasa V. Napot siya sa W. Man si U nasa B mode W. Man si W, inner product U, 0. So kung si U nasa B mode W, man ang inner product nila, 0. Si W naapod sa B mode W perp. Are you with me? Ka na kay arrow. Okay? Ngano ni siya tinuod? Okay, asa si W? Si U nasa B mode W. So kung nasa si U nasa B mode W. Tungod kay si U nasa B, gilet man na nato man. Atong napakita Tungod kay si W nasa W, man si U nasa W perp, 0 na siya. Pero naaman po ni si U sa B mode W. So, ibig sabihin, si W nasa B mode W perp. Mauna siya na conclusion. Hence. So, naa siya sa V. Si W nasa V. Dinhi. Manapot siya sa B mode W perp. So, asa man na siya. So, ibig sabihin si W nasa V intersection B mode W perp. Meaning, si W nasa B mode W, which is what we want. And nagsugod ta sa W, nasa W, napakita nato na si W na si B mode W. Ibig sabihin, si W subset lang sa, di ba, kung A subset of B. Sa ang pagpakitaan na, mo choose kag arbitrary element sa A, kung mapakita nimo na si X na sa B, then it means that A is a subset of B. Nag-choose ka din napakita nimo na naapod siya din so ibig sabihin W is a subset of B mode W. Nanong kinahanglan ni siya sa lemma 2.1F? Dapat mapakita nimo siya na subset. And then next, ang iyang dimension. Are you still following? Are you still following?
Yes, ma'am.
Okay. So, kini na statement din tungod kay napakita nato si W nasa W, man after some argument, napakita na ko na si W nasa B mode W. So, ibig sabihin, pasabotan na W is a subset of B mode W. Okay? Secure. That is how you prove that A is a subset of B. Choose an element of A. Show that X also is an element of B. So A is the subset of B. So this is important because what? Because lemma 2.1F has that assumption. You have to show that. Next, you have to show that the dimension of W is equal to the dimension of, kaya atong gusto ipakita, equal man sila. So you have to show the dimension of W is equal to the dimension of B mode W. Now, lemma 2.8b, given that the dimension of B mode W is the difference between the dimension of V and dimension of W. Also, again, by lemma 2.8b, the dimension of B mode W is the dimension of V minus the dimension of B mode W. Substitute. So you have the dimension of W. Again, you have this lemma here and shown that it is equal, and you have shown that W is a subset of B mode W, so that these two subspaces here are equal. So actually, B mode W is just your subspace W. Questions? So we applied in these two result lemma 2.1F. So actually, in showing equality of subspaces, this theorem is very helpful of its application instead of showing subset, no? Okay, ang usual manggod sa set theory, A equal to B sa set. Gusto nimo na equal, A is a subset of B. Muna imong i-show and B is subset of A. So sometimes this approach is difficult. So ang isa clear pero ang isa dili kaayo clear, no? So the solution there is to use this result, lemma 2.1f. Next, theorem 2.10 in Arnold. Recall ni na subspace, no? This is familiar to you. Katubitong sa early part sa chapter 2. If you have a square matrix A, if you define a subspace, such that every vector in that subspace is R to the n, and A is n by n, C is n by 1. So this vector here is n by 1. Any vector of the form A times C for some vector C is a subspace, no? So V here is a subspace to be an image of A. Then A is actually your projection. If and only if A prime is A and A squared is A, meaning A is a projection and A is idempotent. So this is a projection. This is the property of being an idempotent matrix. So it is an idempotent matrix if A transpose is equal to A and A squared is equal to A. That is being an idempotent matrix. So if your matrix A is the projection, so actually if A is your projection, mahimo na siyang projection of Y unto C. Projection of C unto Y, but kanang C n by 1 man na siya. So vector na siya. So similar na siya sa the projection of Y unto V, where your Y here is actually your C. So any subspace that is in terms, that can be written in terms of projection, then this A here is an idempotent, should be idempotent, no? Okay, so if A is the projection by theorem 2.5H, katong projection of square is equal to the projection, and the projection prime is equal to the projection. So this way of proving is very easy using 2.5H. So is my screen still following?
Wala na, ma'am.
Wala, ma'am.
Kanina pa?
Taod-taod lang, ma'am.
Okay. Is it moving now?
Yes, ma'am.
Okay, so let me again discuss theorem 2.10 of Arnold. And remember this type of subspace, no, wherein every vector in this space can be written as A times C for some vector C. This is C here is n by 1. A here is n by n. So your vector in V here is n by 1. So if in particular, kining A nimo is the projection according to this theorem, that is only true. This equality is true if your A is idempotent. So ang idempotent matrix is when its transpose is equal to the original matrix and its square is also equal to the original matrix. This direction here is easy because of the result in 2.5H, wherein if your A is the projection, then the projection square is just equal to the projection, and the transpose of the projection is equal to the projection. So very easy using this theorem. Now, let's go to the other way around. That is, suppose that your A are idempotent matrix and show that this matrix is actually the projection. The projection, no? Para mahimo siyang AY or equivalent AC, no? So to do that, let a vector V be AY. So kay inaana mag-itsura ang atong mga vector ana na space. Kini siya. Kini na space ang gina-consider. So any vector in V is of the form AC, where C is n by 1. So suppose our vector is AY. So we want to show that V is actually the projection of Y, and V is actually the projection of Y unto V. Para kini siya, mahimo ni siyang A, no? Kaya ang atong gusto ipakita that A is PB. So to imply that A is your PB. Okay. So since V is a subspace, then V is in V. So V is in V. Kay projection man ta, Y minus V should be in V perp. So we now let any arbitrary W to be in V. We want to show, para may siyang projection, definition sa projection, kung naa kay vector V, projection na siya kung atong gusto manggod na ang V is projection of Y unto V. Para mahimo na siyang AY, no? So kung projection siya, dapat V nasa V and then Y minus V is in V perp. So Y minus V atong pakita na nasa V perp. So mag-arbitrary W ta na nasa V. Kuha na to ang inner product. This is how we define Y minus V because V is AY. Uman si W, tungod kay naapot siya sa V, subspace, ang itsura sa atong mga vector sa V kay mga inaniman, AC, no? So suppose naapot kay vector na C, n by 1, multiply by A. Dapat naapod din siya sa V kay na nag-itsura ang mga vectors sa atong V. So suppose mao ni itsura sa W, AC. And then this is just applying the transpose of a vector. Inner product UV is U prime V, no? So naka U prime V. And then i-apply nimo ang prime, so Y prime, okay. A minus B prime is just A prime minus B prime. which is this. Pero si AY, mahimo na siyang Y prime, A prime. And then, ihatag sa isa-isa. So you have Y prime AC. And then Y prime, A prime, AX. Now, A prime A is just actually A because A prime, idempotent. So kining A prime may mong A is A squared, but A squared is A, no? So that's why this A prime A here is just A. And then difference is equal to 0. So this shows us that Y minus V is in B perp. So which implies that V is a projection of Y onto V. And how we define V to be AY, it means that A is PB. Okay? So that is the proof of this theorem 2.10. And B says here that if your A is the projection, then the dimension of V is equal to the rank of your A, which is equal to the trace of A. Okay. So we use this result to 2.1e and look at its assumptions. It says here that this one, (2.1e) kung na kay x, n by p rank sa x is r. So, ibig sabihin si x is not necessarily full rank. R siya. So, R should be less than n or R is less than P because the rank of a matrix is the minimum of X and P if it is a basis. And then if we define subspace with vectors of the form XA, A is RP, and W are vectors of the form X prime V equal to 0. Then the dimension of V is R, or it takes the rank of X. And the dimension of W is N minus R. Okay? So ang atong subspace V takes the form of AC. For some C are dimensional. So this directly follows that the dimension of V is equal to the rank of B is the rank of X. But our X here is RA. So that will be equal to the rank of A. And theorem 2.5i tells you that it's equal to the trace. Theorem 2.5i, it tells you here that if the dimension of V is P, then the trace of PB is P. So whatever is the dimension of V, that will be the dimension of your projection, which is P. So since the rank of your X is equal to the dimension of V from this lemma 2.1e, then that will also be the the dimension will be the trace of your PB is equal to the dimension of V, which is the trace of PB or your A, no? So this is just using two results, 2.1 E and theorem 2.5I to prove B. Okay. So that's it. Chapter 2 is done. So prepare for your first exam on chapter 2. So the exercises will be due sa karon. Today is March 3. Exercises is due March 10. So let's have your first exam on March 18. Can I schedule that? Exams will be every Friday, no? Early morning. So if
Klase
that-
may Sir Baviera Friday, ma'am.
sa oras?
9 to 12.
Lagi, early man ta. Unsa na dayon yung kang Baviera? By the way,
Wednesday and Friday, ma'am.
Wednesday na day, dili na day MTH.
Dili na, ma'am.
Kaya nga, kuha ang na kung MTH. Oh, MTH man ko. Unsa gani original ni Baviera?
Na ay MTH nga.
Di ba MTH na si special topics?
Oh, yes, sir. Ay, ma'am.
Dito
Special
na day.
topics.
Dito day na sa PhD nag-conflict man, nag-change sila schedule. What I know, it's PF yata na sila. PF na 9 to 10:30 yata to. Hindi.